Hi, this video is still in the electrochemistry chapter, chapter 20 in our textbook, and it's our first video on electrolysis. So what exactly is an electrolytic cell? We spent a lot of time talking about a galvanic or a voltaic cell. Well, an electrolytic cell is pretty much just the opposite of a galvanic cell. In an electrolytic cell, you have to pump electricity through a non-spontaneous cell. Let's go ahead and do a comparison between a galvanic and an electrolytic cell. So what did we learn about the galvanic cell? Well, first of all, we learned that a galvanic cell, the reaction was spontaneous. And so we know that something is spontaneous when delta G is negative. In an electrolytic cell, it is non-spontaneous. And so our delta G would be positive. All right, in a galvanic cell, our potential of the cell was positive. In an electrolytic cell, our potential, or our E, is now negative. In a galvanic cell, we have something called a voltmeter that is measuring our electron flow. And in an electrolytic cell, you're going to see a power source because we need something to push the electrons through this cell. In a galvanic cell, we are using a chemical change to produce electricity. And in an electrolytic cell, we are doing the opposite. We are using electricity to produce a chemical change. All right, so yeah, they're pretty much opposite, aren't they? All right, well, let's get some definitions out there. So an electrolytic cell, we've just basically defined. An electrolytic cell is where we're going to use electricity to produce a chemical change. So we're using electricity to produce a chemical change. And you're going to hear the word electrolysis, and that's just the process where we're going to be forcing current to produce that change. Now here's what's important, an amp. This is going to be a unit for us, and this is really important. An amp is defined as a coulomb per second. So whenever you see amp, just write down coulomb per second, okay? Because that is, it's going to be a measure, it's basically a measure of how fast the current is flowing. So it's a coulomb per second. And a Faraday, and we briefly talked about this, it is 96,500 coulombs per 1 mole of electrons. All right, so this constant is generally given to you, but you need to know the definition of an amp. All right, now we're going to do some problems, and these are basically dimensional analysis problems, and they're really easy. You just need to use your units to help you cancel things out. So let's calculate the amount of time required to produce 1,000 grams of magnesium metal by the electrolysis of molten magnesium chloride using a current of 50 amps. Oh yes, when I see amps, I'm going to say what? I'm going to say that it is a coulomb per second. There we go. All right, so what should we start with here? Well, I think I'm going to start with 1,000 grams of magnesium. And it looks like that's 4 significant figures. And let's go ahead and look at what's happening here. We are going to produce magnesium from this magnesium 2+ ion. So it's going to gain 2 electrons to produce magnesium. This 2 electrons is very important. Okay, so we've got 1,000 grams of magnesium, and we know that a Faraday has moles of electrons in it, so I think I'm probably going to have to convert these grams to moles. All right, and a mole of magnesium has a mass of 24.3 grams. And for every mole of magnesium that's being reduced here. So this is a mole of magnesium. For every 1 mole of magnesium, we're having 2 electrons being gained. And so now we have electrons. This is 2 moles of electrons. And we know that Faraday's constant is 96,500 coulombs per 1 mole of electrons. And wait a minute, 50 amps, and amp is a coulomb per second, so let's turn it upside down. 50 coulombs per second, and we've got our answer. We've got our answer in time. I just let my units walk me through this. You know, whenever you have grams, go ahead and get to moles. We get moles, then we're going to convert to moles of electrons, because how many electrons are being transferred per mole of magnesium? It's 2. We know what a Faraday is in coulombs per moles of electrons, and we know that amps are coulombs per second. We've got our unit time in the numerator. Again, use those units. It's like solving a puzzle. And to 4 significant digits is how I should be reporting this answer. I'm getting something around 158, 500 seconds or so. All right. All right, again, just using your units. All right, let's try something else. So we've got chromium. Oh, is that the right answer, by the way? Yeah, okay. All right, we have chromium plus 3, and it's being electrolyzed using a current of 7.6 amps, or coulombs per second. What mass of chromium is plated out after 2 days? All right, well, let's go ahead. We got chromium plus 3 electrons to give us our chromium. And we are starting with 2 days. All right, and I'm thinking I'm going to have to convert that days to seconds, because we know that this has the unit seconds in it. So let's just go ahead and get that done. All right, we know that 1 day, oh great, here we go again. The cat, I don't know what it is about every time I do a video, the cat comes. All right, 1 day is, now he's biting my hand, is 24 hours. And we know that there are 3,600, there are 24 hours in a day, and there are 3,600 seconds in one. Okay, this just is not going to work. Ow, he's still biting my hand. I'm sorry. In an hour, ow, ow, ow. And this is just beyond ridiculous. All right, we have, all right, come on, Zeus. This is the troublemaker again, the troublemaker. All right, so we know we have 7.6 amps, which is 7.60 coulombs per second. These seconds have canceled. All righty. And now we've got coulombs, and let's see, we know that a mole of electrons is 96,500 coulombs. And we have 3 moles of electrons being transferred for every 1 mole of chromium. And then we just have to do our last step and get to the mass of chromium, and a mole of chromium has a mass of 52 grams. And when we do all of that, we should get an answer of 236 grams to 3 significant digits. Okay, again, dimensional analysis, remembering the definition of an amp, using your units to help you through the problem. All right, let's try one last one. What amperage is required to plate out 0.250 moles of chromium from a chromium plus 3 solution in 8 hours? Alrighty, so we are looking for the unit when we are done of coulombs per second. And so let's just keep that in mind. We want coulombs per second when we're done. And we've got chromium plus 3 electrons. That 3 is important, giving us chromium. All right, so let's go ahead and on this one, let's see, we are starting with, let's see, 0.25 moles of chromium. And that's in 8 hours that we're doing this. Okay. And there are, per mole of chromium, there are 3 moles of electrons. And let's just get those hours to seconds here in a minute. Let's do this 96,500 coulombs per mole of electrons. Okay, so now we've got coulombs per hour, but we want an amp, which is coulombs per second, and we know that an hour is 3,600 seconds. And when we do that, we should come up with to 3 significant digits, because this is 3 significant digits. That ending 0, there's a decimal present, is significant. It is 2.51 amps. All right. Dimensional analysis. I kind of think these are fun. It's like a puzzle. You're just putting in your units and making sure that they cancel and answering the question. All right, this is part 1 of electrolysis.